Bismillahirrahmanirrahim. Assalamu alaikum dear students. I welcome you to the next session of the C refresher video lectures. Today we are going to discuss input and output in C. I mean how a C program reads the input that is to be processed and how a C program writes the output after processing. I/O in C. Let me write it down. As far as the I/O is concerned, we can perform the I/O by using high-level library calls, or we can use low-level routines, normally called system calls. For the time being, remember, as far as the high-level I/O is concerned or the library calls are concerned, the buffer management is implicit, while in case of system calls, buffer management is the programmer's responsibility. Okay, roughly I can divide the I/O in three main categories. One is known as the terminal I/O, which we are going to talk about today. The other is known as the disk I/O, and the third one is port I/O. Today we are going to talk about the terminal I/O, and some other days we are going to discuss the disk as the port I/O. Remember, as far as the terminal I/O is concerned, you can perform this I/O either in the canonical mode or in the non-canonical mode. Well, we must have talked about the canonical as well as the non-canonical I/O in some previous session of operating system. Let me refresh your memory by saying that the input keyed by the user goes to the process only when the user presses the enter key. This is the canonical I/O. By default, the bash shell as well as all your C programs work in canonical I/O. On the contrary, in case of non-canonical I/O, as the user presses a key, it is sent to the process without the need of pressing the enter key. Normally, all the editors like Vim work in non-canonical mode. Similarly, you all must have used the more command. That is another example that works in the non-canonical mode. Today we are going to talk about the basics of terminal I/O, how we can do this in a C program. Let me talk about the theory a little bit. Suppose this is our system having the user space over here, and there is a process P1 executing in the user space, and there is a user who wants to interact with this process using a device that is known as a terminal. And we all know that a terminal is composed of a visual display unit that acts as an output device for the process. That is, this process can write on this video. Similarly, there is another component that is shown over here, that is a keyboard that acts as an input device for the process. That is, a process can read character from the keyboard. Okay. Now, let me move on to another board. and see what we can discuss in terminal I/O. By terminal I/O, I means the I/O that deals with the keyboard and the monitor. Roughly speaking, we can divide the terminal I/O into two parts. One is known as the formatted I/O and the other is known as the unformatted I/O. In formatted I/O, we have the two famous functions. One is the printf function that is used for output, and the other is known as the scanf function. And if we talk about the unformatted I/O, we have the getchar and the getS. These two are the unformatted I/O functions for character output and for string output. And we do have putchar and puts. These two are for the output, for character as well as for string. Remember, gentlemen, this function getS, you must not use this getS function as this is deprecated. This is one of the biggest reason of buffer overflow in different programs. So it is always better, if you want to do unformatted I/O, use the getchar and the putchar functions. Before I start discussing the formatted and non-formatted I/O functions, let me have a brief comparison between these two. Well, gentlemen, in unformatted I/O, the input and output is treated as characters and they move between process and terminals without any conversion. The data that moves towards the terminal, or the data that moves towards the process, that moves as ASCII encoding. If you want to read numbers, integers or floating point numbers, using these functions, that is unformatted I/O functions, you first read characters and then convert them to appropriate data types. On the contrary, in case of formatted functions, formatted I/O, you can specify whether you want to read a character or a string or an integer or a floating point number. So first of all, let me talk about the famous printf function. Let me write formatted output using printf. This is one of the C function that processes variable length arguments in a very portable way. Let me write down its prototype. Int printf. We have a format string as the first argument, and then we have optional various number of arguments. The only required argument is this format string, and this format string can contain characters that need to be printed as such on the screen, escape sequence, characters like \n, new line, tab. Then the third thing is the format specifiers. These format specifiers, they basically defines the output format of each argument, each of these arguments. And the format specifiers can be %d for integers, LD for long, LLD for long data type, %f and %e for floating point numbers, LF is for double, %c for character data type, S for string, O to display numbers in octal format, X for hex, P for printing addresses of pointers, and so on. Each of these conversion specifiers begins with a percentage sign, and it may contain something over here, and it ends with a format specifier like, for example, F. What can be over here, we will talk about this a bit later, but right now the point you need to remember is, if at all you are going to give any arguments to the printf function, they should match in number, order, and type with the format specified mentioned in the format string. For example, if you have mentioned 3 format specifiers in this string, there must be 3 arguments. If the first is integer, then float, and then string, they should appear in the same sequence and order over here as well. And finally, the printf function returns the number of characters printed. So let's move on to the terminal and start playing with the code to understand properly. Okay, so let me cat a program I have written for you, op1.c. So you can see this is the first printf statement, the famous hello world. Only one argument is passed to printf, and that will be printed, and there is escape sequence, that is the \n. New line will be printed after that. I have created a string Muhammad Arif Bhatt. This string is printed with %s. Over here you can see a number 30 written between the percentage and the format specifier. This is the field width, and if you write a negative sign before, that means that you need to left align the string. And if between percentage and s sign you have a decimal and a number after that, that means you want to print only 8 characters from this string. And 30.8 means field width is 30 and print just 8 characters, and minus means again left aligned. So let me GCC. So you can see the hello world Muhammad Arif Bhatt, and over here you can see this Muhammad Arif Bhatt because it is right aligned due to this, and it is left aligned, and this is only Muhammad, that is the 0.8 characters, and this is again field width of 30 and 0.8 characters. So remember, gentlemen, a number of written between this means the field width, and number written after the decimal sign means you want this much number of characters to be printed on screen, and this is for the strings. And similarly, if we talk about the floating point values, this number on the right of the decimal means print this much number of digits after the right side of the floating point number. Let me show you another program. In this program, you can see I have created a character and I have displayed that character. The format specifier is %C. So whether you initialize this character with A or 65, you will get an A over here. Format specifier is D, so you will get an integer value over here, that is 65. And then the format specifier is O, who will have an output in the octal format. X means hex format and P means the address of this. And of course I have written an ampersand over here as well. Let me compile this program op2.c. Let me clear screen. Let me cat this program so that you can have a comparison and understand how we can display a character at a time. This character, this is integer, this is in octal format. Remember, this 101 is the octal value corresponding to 65 decimal, and this 41 is the hex corresponding value of decimal 65, and this is the address. This is the 48-bit logical address. You can pad it with zeros on the left side. Okay, so after strings and characters, we can talk about the integers. Let me talk about let me show you another program, op3.c. Over here you can see there is an integer number over here, and I am printing that number. This is the field width again. This is the field width. We have a 0 over here, that means it will be padded with zeros on the left. Let me compile and run this program so that you can have a comparison. Over here we have field width of 10 padded with zeros on the left, padded with zeros on the left. And then we have a negative sign over here, that is left aligned, and we have no sign over here, that is right line. Okay, so let me talk about floating point numbers as well. So we have a double value 652.34587382. We can display it in long format. Once you display it in long format, it will show almost 6 digits on the right of that, 1 2 3 4 5 6 values. And over here I'm saying just display 3 values on the right of the decimal value. Over here we have a field width of 15, total 15, and it is right line, and with a minus sign it is left line. And then we have a lot of new lines, and over here the E format shows you the same number in exponential form. So gentlemen, using printf you can easily print characters, strings, integer numbers and floating point values on your screen. So before I talked about the input, let me move on to the board again and show you the formatted input function. Talk about formatted input function. Formatted input using Scanf. This is a bit tricky. You need to understand few points if you want to work it properly. If you want to work properly with the Scanf function without issues. Let me write the signature of it first. Okay, fine. This scanf function must be passed at least 2 arguments. It must be passed at least 2 arguments, this one and this one, and maybe more. Basically, scanf scans input line from keyboard or std-in according to the format specification string, with spaces as delimiting character for each argument. You can view the man page for details. However, this format string contains format specifiers which are almost same as discussed in the previous slide. For integers, for floating point, for doubles, for character, for string, and so on. If more than one arguments are given, for example, if you have given arg1, arg2, and another arg3, there has to be 3 format specified mentioned over here. And they must match in number, order, and type with the format specified mentioned in the format string. For example, if you are expecting an integer first, then a floating point, and then a string, the same sequence should be here over in the format string. And remember, the scanf function returns the number of input items successfully matched and assigned. Okay, there are more details and tidbits as far as the scanf function is concerned. I think it's better that we should move on to the terminal to understand it properly. Okay, let me show you the first program that I have written, a very basic program. So this is a portion of the program that creates an array name and prompts the user to enter the name and inputs a string. Then it inputs the age and gets it in an integer variable. And over here I ask for the CGPA and I get it in the CGPA variable. Remember, the arguments to the scanf function are always pointers. And then finally I have the printf statement in which I have given these 3 specified string and then integer and then the floating point value, and these are displayed correspondingly over here. Remember, if I have written a string over here, the string argument should come first and the integer argument should come second and the floating point should come at the end. So let me clear it, let me GCC, compile it, and let me execute it. It has asked me for the name. I give Arif, 45 is the age, and 3.87, let's suppose, is the CGPA. So it has displayed, Mr. Arif, you are 45 years old with a CGPA of 3.87. Good luck. Okay, so it's fine. Let me run it again with let's suppose I want to run it with Arif and but, and you see a different behavior. It hasn't prompted me for the age, it hasn't prompted me for enter your CGPA, it has just displayed some garbage values in the final string. What has happened? To understand it, we go step by step. Let me first revise again. This was a program that was working perfectly fine if I enter a name without a space over here, then my age, then my CGPA. But it behaves differently if I give a longer name and name with the spaces over here. What is happening? Let me show you another basic program that is creating the 3 variables and prompting you to enter the 3 values in one go. The scanf is prompting you for the name, for the integer age, and the floating point CGPA, and it is displaying with the printf statement. Let me gcc input2.c ./a.out. Remember, it is asking me for name Arif space 45 space 3.87. Enter. It's working perfectly fine. Remember, gentlemen, the scanf scans the input line from the keyboard according to the format specifier string, with space as delimiting character for each argument. So the first argument is Arif, the second is 45, and the third is this. This goes to a string, this goes to an integer value, and this goes to a floating point value. Working fine. Let me run this program again. And now I give 45 first and then 3.87 and then I say Arif. You see, this 45 goes to the name string as such, 45, without any change. This 3.87, from this 3.87, this first 3 is going to the integer value, that is 3 years old. And now this remaining 0.87 goes to the portion of the floating point value. And this Arif is still there in the input queue. This is not assigned to any of the arguments. So, what to do now? Let me run it again. And let me say Arif but, is my name. I want Arif to go in name. 45 is the age, and 3.87 is the CGPA. Once again, you see, Arif has gone to the name, but after space, this but has not gone as part of the name. Rather, this has gone to the age value, and age value has been converted to some integer value to this garbage value, while this is not required. So let me handle the first issue. I want to input a name, a full name with spaces in between. I should be able to do that. Let me show you another program. In this program, I am just prompting the user for a full name, and I am using something between percentage and S sign. There is a straight bracket, and in that I am saying not \n. This is basically read as long as the character inside this bracket is not encountered. So scanf will keep on reading the line, the characters in the line, including spaces, until and unless it encounters the \n. Let me do this, and let me say my name is Muhammad Arif Butt. So you see, it works perfectly fine. Once I press enter, the complete string that I have entered, Muhammad Arif Butt, has been assigned to this pointer name. Okay, so let me show you another program now. If you have understood this, see this program. Now what I want to do is, I am prompting the user to enter marks in operating system and system programming, and I am reading those marks in one go, that is space separated. Then I am prompting the user to enter marks in DLD, and I am reading the marks in DLD once, and then I am printing the values. Okay, let me gcc input 4.c ./a.out. Now I remember that I need to enter marks in OS and SP. Let's suppose I have 85 marks in OS and I have 81 marks in SP. And then it is prompting me marks in DLD, and I have got 92 marks in DLD. And it is showing me the marks in OS are this, SP is this, and DLD is this. The program is working fine. Okay, so let me run it again. And let me give marks in OS 85, marks in SP 81, and let's suppose I have given a third argument as well over here. Instead of giving two arguments, I have given third argument as well. Now you note it has displayed this prompt, enter your marks in DLD, but it has not hearted on this scanf and just has displayed the output. And the beauty is that the marks 92 has been assigned to DLD. So remember, students, any unread data item argument, 85 is assigned to OS, 81 assigned to SP, and 92 is unread. Any unread data item argument in the queue will be considered as part of the data input line to the next scanf call. So this 92 goes to this scanf call implicitly. So remember, whenever you are using scanf, this entire line will be assigned to the arguments. If there are more arguments in this input, they will be left in the input queue and they will be assigned to the arguments in the next scanf call automatically. Okay, let me show you another example. In this example, what I am doing is, I am prompting the user to enter the full name, and I am reading the name including spaces, and after that I am asking for the age, and then I am displaying both the values. GCC input 5.c, Muhammad Arif what, and age is 45. Okay, and it is working perfectly fine. Okay, let me make a change in this program. Let me copy it, input 5.c to temp.c. Let me just delete these 3 lines and paste them over here. What I have done is, instead of taking the input the name first, I am inputting the age first. That is it. There is no change in the program. Let me save and quit. gcc temp.c. Let me run this again. And it is asking for the age. So let me enter the age 45. So I entered the age 45 and it has displayed this prompt, enter your full name, but it has not waited for me to enter the name. Rather, it has just printed the output and shown me a garbage value. Let me show you this program again, temp.c. Try to understand. Once I write 45 and press enter, the 45 goes to this variable age and the enter is still there. The new line character is still there in the input queue. Once this scanf executes, it encounters the new line character already there in the input queue. So it just assigned the new line character to this variable name and executes this line. So let me repeat this concept again. What this program is doing, it is prompting you for age. You enter 45. The digit 45 is assigned to this age, and the enter that I pressed after entering 45 is left there in the input queue. And that new line character is assigned to this name. And since it has to terminate the input on the new line, so it doesn't halt over there. Let me execute it again. 45 and new line character, and you see. So let me cat temp.c. So the problem is after this scanf. So we have an issue after this scanf. After this scanf, the age is there in the age, 45 is there in age, but we have a new line character already there in the input queue. So what I need to do is, I need to eat that up. I need to remove that. This scanf should not read that new line character. So to solve the issue, let us eat the new line character by editing this temp file. Like suppose I say character CH, a dummy character I have created, and I have used the scanf, and I have tried to read a character and CH. Now the new line character that is there in the input queue after you input the age will be read by this CH, and now once this scanf executes, it will halt to get the input in your name. So let me run. I have entered 45. You see, the enter has gone over here, and now it is waiting for the name. So now the program is working fine. So let me rephrase everything what I have done right now. Remember, once you read a string using the scanf, the enter key or the new line character you press at the end become part of the string. It becomes part of the string. And after that \n, there is a \0 placed over there. In case you are reading a number, the \n you press at the end of the input string does not become part of the number. It does not become part of the number. So that is still there in the input queue. So in case you read a string with spaces using scanf, the new line character you press at the end does not become part of the string. And here the new line character is still there in the input queue. So that is being eaten up with this scanf. And if you are reading the name first and after that you are reading the age, there is no issue, as we have seen before as well. Some other points that you need to keep in mind while using scanf are never end the format string with a white space at the end. Never put a white space over here. If you do this, it behaves differently. It might wait for another data item after you press the enter key. Then the field width specifier, you should not use field width specifier while using scanf. However, if you use them, they should be large enough to contain the input data size. So please practice all these issues. If you practice them properly, I hope Scanf function will not disturb you much. Okay, let me move back and let me now move to the unformatted I/O. Well, students, after seeing the formatted I/O functions, let us now discuss the unformatted I/O function that reads and writes from stdin and stdout respectively without any implicit conversions. So as I've already said, you should not use getS as it is deprecated and is the biggest cause of buffer overflow problems. So you should preferably use the getChar and the putChar functions that reads and writes from stdin and to stdout character by character. Let me write down their signature. You can see the man page as well. Int getChar is used for input. GetChar reads the next character from stdin one by one and returns it as an unsigned character cast to an int. Then we have the int putChar. It writes this character C cast to an unsigned character on stdout, and it returns the character written as an unsigned character cast to an int. So instead of going to the theory, let's again move to the terminal and see what we have over here. So I have written simple programs to save the time. So this is the getChar function. This returns a character that is stored in this integer variable cast to an int, and this is the putChar function that reads the value of this variable xtr and prints it on stdout. Let me gcc and run this program. I press B and you see B is printed on screen. I press this B and B is printed on screen. Okay, so let me now execute this program again and let me write down ABC. So once I press enter, this A goes to this character. This BC remains there inside the input queue, and only this first character is printed on the screen. Remember, once I press enter, only then this is available to the process, and this getChar just eats the first character, not the rest of the characters. Let me show you another program. 2.c. Over here, let me make it a bit more simple by deleting this line. Over here we have two getChar functions. The first getChar function assigns the first character, the second character, and then I print both the characters. gcc 2.c ABCD, and you see the first two characters are being displayed, and if I do A only, it's behave differently. Let me show you again. 2.c. I press B and I press enter. The B goes to character 1 and I do not halt over here because the \n is still there in the input queue. The \n is assigned to character 2. Remember, the B is assigned to character 1 and \n is assigned to character 2. And if I write A, B, C, D and press enter, so we have 1, 2, 3, 4 and the \n 5. There are 5 characters in the queue. This getChar gets the first character and this getChar do not wait, it just eats the second character in the input queue and assign it to xtr character 2 and displayed it over here. So, maybe if you think that this is not the case, and you want that user should get first character first and that it should wait for the second character and the second character should be assigned to this, we need to eat the \n from the input queue in between these two calls. Let me vim 2.c and now let me add that line in between over here. I just say getChar. Now remember, I press A, that goes to character 1, \n stays in the input queue, that \n is assigned to this getChar function, and now the input queue is empty, so this getChar will again wait for another character to be given by the user. Let me compile this 2.c. You see, I press the first character B. This B is going to be assigned to character 1, and the enter which I'm just going to press now will be eaten by this getChar, and the program will halt on this getChar. You see, now the program is waiting for input in this function, and I press C. Now once I press enter, the enter will be there in the input queue. Putchar will display B over here, then a C over here. You see, B and C, and there is no new line. We have the prompt after this. Okay, let me show you another program. So over here, what we are doing is we are prompting for a character and assigning it to xtr in an infinite loop. And until and unless we get an end of file, we repeat this loop. So we get a character, we put that character, we get a character, we put that character until we get an end of file. So let me compile, let me execute, and let me say Arif, but learning C is fun with Arif. Okay, bye. So what is happening is, I have pressed these 10 characters, 9 characters of name including space and a new line character. They are read one by this and put one by one on the VDU. And then a new line has brought me down here, and then a new line has brought me down here, and so on. And finally, once I press Ctrl plus D, which is the end of file character, I came out. So this seems to be good. Let me do something else. Copy 3.c to temp.c, and let me make a little change over here. Instead of this end of file, let me put a new line character here. Now this program says that keeps on reading character by character from the keyboard until you come across the new line character. See? So once I write Muhammad Arif but, that is assigned one character by one character to this xtr, and that is placed on the screen character by character until I have pressed the new line, and the new line is of course not printed on the screen. Okay, so that is fine. Let me do something else now. Let me copy this program to a program file name like changecase.c, and let me repeat it till end of file, and in over here with putchar let me write down to upper. To upper is a function that is defined in a header file is required like C type. Okay, so I think it will work. It should work. It will read characters and it will display them in uppercase. That is it. Oops. To upper. So we have issue in the include directive. Must be a typo. include seems to be fine now. Let me compile again. It has worked. So Arif, but you see it has changed it to uppercase. Oh, let me show you another thing. Okay, I just want that if I execute this program with a name of upper, it should print in uppercase, and if I execute this program with the name of lower, it should execute in the lowercase. So let me use command line arguments. Int argc, character pointer argv. Okay, so I check out, use a string comparison function strcmp argv sub 0. If argv sub 0 contains a string dot / upper, in that case I should do this. Yes, to upper. And if that is not the case, then let me copy these two lines over here, and I need to do a to lower. I think it's fine. So I compare this. If the program name, if this piece of code is called with the program name upper, it will change to upper, and otherwise it will change to lower. And then strcmp, I think I need to add string.h over here. Hash in, sorry for the typos, string.h. Okay, so let me try it. Hope there are no typos in this. Yes, there are no. Okay, the main thing is that I want to compile this with the name of upper, and I need to compile this with the name of lower. Now I can call it the name of upper, and it changed to upper. Control D. Let me call it the name of lower, and it changed to lower. So fun. See again, it's very simple. I check the name of the program with which this program is called. If it is called with / upper, it changed to upper, otherwise it changed to lower. So that is good. Now, gentlemen, that we have seen, we have a fair idea of how these two functions, getChar and putChar, works. Let us try to write a program that input a complete string from the user. I think I have, yes, I have a program. What I'm doing is creating a buffer, entering an infinite loop till I get a \n, and I assign it in this with 0, 1, 2, 3, 4, and so on. So after this loop is done, we have a complete string in this buffer. So let me use this ./a.out. Muhammad Arif but, you see, but there is an important thing you need to understand. A new line has been placed over here implicitly. Remember, over here again, user has pressed Muhammad Arif but and new line over here. So a new line is placed over here and then a null is placed. So whenever you are going to create string using this way, you need to remove that new line character from there. Let me change this program. So after I have taken this, I need to remove the new line character. I have to replace it with a null character. So this is the place where the new line character is lying, so I need to place a null over there. Now this is a proper string. You see? Now there is no new line. Over here there was a new line, implicit new line over here. There is no new line over here in the printf statement, but we are getting a new line over here. And over here we are not getting a new line. So this is good. So remember, whenever you are going to get a string with using this logic, you must remove the new line from the buffer and place a null over there. Now that you know how to input a string using unformatted IO, let us input an integer. Let me copy this create string to a file create int.c. Create int. We need to change the file now, create int.c. So this is the file where we have got this. I don't think that I need a line over here. And after getting number in this buffer, now let's suppose I want to get an integer. So I have pressed 1 2 3 4 5 and that is there in this 1 2 3 4 5. I can use int number is equal to, let me use a function a to I. I can write my own as well, ASCII to int. So it will convert this integer to the numbers in this buffer to integer, and then let me print it using d. Let me write number over here and let me do plus plus over here so that you can be sure that it has been converted to a number. So this way I can get a string in this buffer and I can change it to an integer number. So let me see whether this works or not. Oops, a to I. So I need to use stdlib.h. Hash include stdlib.h. Let me save and execute this. Let me show you the file. I enter 34521. So this is a string. 34521 will be assigned to this buffer, and then a to I will convert it to a number, and this number is added by 1, and you can see this. You can use a to I. You can always use str2l. This is a better function that you can use. There's a new function that you can change the base as well, and you can this converts the initial part of a string pointed to by this to a number up till this address. So you can get a long string and the initial part of the string can be converted to the number, str2l and str2ll for long. Okay, so now we know how to input a string with spaces. We know how to input string and convert it into an integer, and now I need to repeat the same for floats. Floating point value. Let me just change the program that we have just written. So this much part of the program is same, and over here I need to use a to f, and over here float. Probably over here I just use a printing value of f and this number plus. Okay, hope this will fine. This should work. $245.34. Okay, 436,789. You see, 245. It has been incremented to 246, and we have got this. If we mention the Prussian digits over here, they will be printed. Otherwise, it will display 6 digits, and this 3 is just because of the Prussian, because we have used float. If you have used double, this problem wouldn't have been there. The way you can use A to F, similarly you can use str to F. So this is again a better function, str to F, str to D, and str to LD for long double as well. So we can use these functions as well. Dear students, let me sum up. We have seen how the formatted IO functions like scanf and printf can be used to read and write strings, to read and write integers, and to read and write floating point values from stdin and stdout, respectively. We have also seen how the two unformatted IO functions like the getChar and the putChar, they can be used to read and write characters from stdin and can be used to display those characters to stdout. And we have seen that we can convert these to integers as well as to floating point values using built-in functions, and we can try writing our own functions as well. Important point that you need to remember is that input a complete line with spaces from a user and convert it to a string by replacing the last new character line with a null character. Whenever you are reading a string, you need to replace the last new line character with a null character. And second, you should know how to input an integer value or a floating point value from the user. Whether you are using the formatted IO functions or you are using the unformatted IO functions. That is all, gentlemen. Hope in the next session, inshallah, I will try to talk about the disk IO, and the port IO may be discussed some later time. Hope this session was informative, although I think with nothing new to the second year BS students. But anyway, I thought it appropriate that students must have strong grip on the scanf, printf, and the getChar, putChar functions. Happy coding and Allah Hafiz.